Okay, let's go. I still need a jingle. Hello and welcome to Practicalli. My name is John Stevenson. Thank you very much for joining me. And today we're going to continue with the COVID-19 dashboard that we were working with in video 65. So we started using the Oz library to visualize some data. And initially that was mock data that we just created. And now we've added some real data that I've got from the gov.uk, and we've added some better visualizations, especially of the headline data as well. So we'll cover that. So I have, if it's still there, is it still there? Oh, I haven't done it yet. So we're going to build a dashboard, and I've separated it out into different namespaces as well, so it's more of an application. Previously we just had the design journal with it all in, so I'm going to walk through how I've created it from the design journal into a proper application as well. So if we evaluate that, so this is what we've got, and it's all using real data from the gov.uk website as well. Ooh. Though I'm not too sure about the dates here, but they are accurate dates. They're just quite verbose. So we'll go through how we built this, which is a bit of difference from what we did originally. Oh, that's gone back to where it started from. Boom, boom, boom. I'll show you what we started with. Where we left off last time was here. And so now there's a bit of a difference. So we had the graphs, the scatter graphs, bar and line graphs there, and now we have something that looks a bit more professional, something that you might be a bit more inclined to actually push onto the internet. Again, this is just taking data from gov.uk. I'm not trying to estimate or kind of give any comment on the actual figures or how good the figures are. This is more about how to get those figures, get the data, and visualize it. Okay. So before we start, then, if you want to get in touch with me or see any other the videos we've got. Oh, sugar! I'm not showing you my screen. Sorry. I'll start again. Hello. So last time we were working on the dashboard like this. So we used Oz to visualize line plots and bar charts, and also included some headline information about the COVID-19 cases. And this is quite interesting, but I couldn't find anything in the Vega setup to visualize this information very nicely. So what I've done is added uses some Bootstrap and created a much nicer dashboard with all the real data there on there, and so it's a lot easier to kind of read the data and see what it is. It looks a bit more professional. So we're going to walk through how we've gone from this basic view, this basic dashboard, to a more professional looking dashboard. Okay, yes, if you want to see any of the other videos practically, they're all on the practicalli.github.io websites. The Spacemax book is fairly well developed. I'm going to redevelop these books based on Clojure CLI tools and deps.edn. So I'm already started the Clojure book, or started refactoring this using kind of REPL-driven development, using REPL readline, and how to create a project with CLJ, Clojure CLI tools. So I'll be working over that in the next few weeks. Any feedback is most useful. And if you want to get in touch with me, then Clojure in Slack on the Practicalli channels, very useful way to do that. And there's a link there how to get your account if you don't have one. And there are other ways as well to sponsor me and motivate me and keep me going. Everybody who's contributed so far, I'm much appreciated. It does help me understand that people are actually enjoying this content as well. So thank you very much for that. Okay, so how do we get from here to here? That is a good question. Well, where we started off, if we go to my editor, if you downloaded the code before, it's been updated now on GitHub. But I had basically a design journal, which is here, where we create some mock data, and then we did some line plots and some stack bars, so bar charts, and dashboard, and then I created a dashboard just using very basic so like hiccup style syntax. So it's kind of very basic text that was being displayed. So this is just HTML but in Clojure form with the keywords here as the tags, the HTML tags we're going to use. And then we started reading in sort of the data from CSV files. So I was downloading the documentation from the government website. Oops. So there's a government website here with their tracker information, and you can download these data that's driving the dashboard. So they have their own dashboard, which is what I was trying to emulate. So I've kind of got this bit emulated. And so all the data from this is in here, but they're actually just files you download. So and some of them are Excel files. So I converted them to CSV initially, and then just used clojuredata.csv to import them. And then doing a bit of zip maps to basically create sort of the shape of data I wanted, because I had the two vectors, one with a headings, or the headings of the comma separated values file, and then one with the values. So it's basically just a 2-row CSV file, the headings and the data, and then I just use zip map to glue them together so we get the headings matched with each of their values in like a normal Clojure map. And then I could use some of the real data in the headlines, but again, this is still just text. So one of the approaches I was going to do was use Bootstrap, but then I forgot I couldn't remember how to use Bootstrap, and it wasn't quite getting me as quickly as I wanted to get. And so I've been using Bulma as an alternative to Bootstrap, and I guess I suggest using whichever CSS framework you know the best, really. And so what I did was, rather than so I created a new dashboard. So define a new dashboard. I still got the Clojure syntax for HTML code, but I did this extra piece in here, which pulls in the CSS framework from its content delivery network. So this is going to pull in the CSS styles for me, and again, it's just this just translates to a normal kind of link you would include in the heading of your web page. So you'd have a link to style sheets, either local or on the internet and a CDN server in this case. And so that's a very simple way to just pull it in. There are other approaches like using webjars, but they're more complex. And as we're kind of doing this, we've got an internet connection. Then this is the kind of the easiest way to get a CSS framework into here. And then I've just created sections. So I created a section for the title. So this is the section. Let's go back to here. Oh. So this is the this section up here. Then I created a section for the headline figures, and then a section for the graphs that I'm creating as well. And so that's just using these section tags. Again, these are just like divs. There isn't really, I don't think there's any much difference using a section or using a div. It's just a way to divide them. It just, I guess, it just is more meaningful to use section because then you can see without having to look at it. And we're using a class of hero, which basically makes the bar across the top, the colored bar across the top. And I'm using the isDark theme, which makes the background color black, and isBold, which just makes all the text sound much clearer. Yeah, that's it there. Oh yeah, so then we've just following the Bulma spec. So basically, if you go to the Bulma website, so let's go there. Oops. Boop. Bulma IO. And if you go into the documentation, it basically just shows you how to create. I think it was layouts and sections. Yeah, there you go. So it gives you the HTML code. And so it's very easy just to write that in Clojure in the hiccup format, because you can just basically use section, div, and so on and so on. So that's what I've done, and just putting the class containers in where necessary. So I've just basically used these HTML snippets and converted them into hiccup. So here we've got, so we're given these classes to create hero body, so that makes sure it kind of spans across the whole page, and a container just to contain the text within inside that as well. So we've got the title here, and I'm just using a particular font, and then I'm using a smaller piece of text here, which is its subtitle. So I'm just using classes assigned with the HTML tags, and this is just a normal link there as well. So with that, I created the top level of this, which has got, and there's a link, even a link there as well. So that's all working quite nicely. That was nice and simple. And then I've used then started writing sort of the columns for the UK totals for the daily headline figures. I created another section, and I wanted to put all the text centered in there as well. So everything that's text is going to be centered all the way through. So we look at there, so you can see all these cards I've created, all the text is centered in there as well, so it looks quite nice and professional. So we've created a column for each of the cards. So we've got columns, and then each card I'm creating. So this card content I've got here, this card is going to be in a column, and the UK totals, I put that as a half. So each of these divs is going to take up half of a column, and so if you've got two columns, then that takes up a whole. Oh, I can do maths. Great. So that's why I've got these two as the two main ones, because they're the two kind of headline values. And then for the country values, then there's 4 countries. That's convenient that there's a nice even number. But so I've done here is 1/4. So each card is going to do 1/4 of the screen width. And these are all the same. So the only difference really is the title I'm using here, and then the actual data. So I'm pulling in some data for the actual values. So this is the cases, and this is the unfortunate deaths. So yeah, I'm just basically using this COVID UK daily indicators map and pulling out the relevant key to get the data, and then just I don't think I need to convert that to a string there. No, probably not. but that means that this code is all kind of the same. So I want to try and avoid writing lots of duplicate code because it's very easy to make a mistake. And also, if I want to refactor how this is generated, then I'm going to have to do it 4 times here and twice here as well. So one idea is to create a little generator function that actually generates all this repetitive code. So let's see. Oh, and is there anything else I did before we go? Yeah, so that's all the so because there wasn't a Vega view for this headline data, then we've created that with Bulma, and then for the actual visualizations from Oz, we just include them in another section, and you just use this vega-lite thing. So this is like calling the Oz view basically, and that will generate the visualization for that particular view that we've created. So we created line, plot, and stack bar last time. Yeah. And so, yeah, so I refactored with the kind of the Bulma code, refactored that in generators. So there's probably a way to streamline this a little bit better as well, but just for help people follow it, I've kept it as, so I've just generated a headline total card. So this is the is half. So this is for the UK totals. And we're just passing in a totals thing, totals value in here. And we're basically just using that to pull out the type of total to get the right value, to get the right key that we need to use for that. So is it cases or is it deaths that we're pulling out? And then, oh yeah, I just hard coded that bit because I forgot. But in this one, I've so for the country cards, then we pass in the country. So we're passing in the alias and the name. So we've got the name for the title and the alias for the key. So this is going to pull out the alias. And the reason I need to use an alias is because of Northern Ireland, because the name of the country is Northern Ireland in full, but in the actual key, they're actually just using NI. So it's NI cases and NI deaths, whereas the title is Northern Ireland. So I just had to create an alias there in the when I'm calling it with country. So I'm calling this with. Have I got any examples where I'm calling this? Oh yeah, yeah. Here we go. Yeah, so I'm calling this with headline country card with the name Northern Ireland, but with an alias NI. So we're just using that alias to look up, to form part of the key that's in the data set that we're actually using. Boom. So if we look at that, can we look at that? Oops, sorry. I don't know if that's... Oh no, it's not evaluated. Okay, so this means that we can, so this is the refactored dashboard. So we've still got the style sheet, we've still got the headline, so the hero or jumbotron at the top. But then the rest of it is a lot more streamlined. In fact, if we swap back to the main here. So now the dashboard. So I pulled the dashboard into the core namespace. So like the COVID-19 dashboard, that's the main namespace we're going to use. So this will be the one that runs when we run this as an application. And if we look at the bottom, so then we've got this. So we've got this main. We've still got a main function in here. So this will be called, if we call this application from the command line. And it's effectively, we just pass the actual view that we want to work with, which is the dashboard COVID-19 UK. And this is what we've created here. So this deft dashboard COVID UK 19. So we've got the section for the heading, and then the sections for the UK totals. It's much simpler code. There's only a few lines of code instead of like 10 lines of code for each card. So it makes it a lot simpler to actually see what's going on. As you can see, that we've got this headline card total generator, and we're passing in some data. We're passing in some data from the gov.uk, and we're basically just getting the this is the name of the data we're creating. So this is going to be the title of the card, and then this is the type. This is the key that we use to get the data from the data set. And so, yeah, so we have each card there, and then because all the country cards are the same, we can just create a map function that will basically go through all these country cards and just generate a card for each of them. So again, we're streamlining what, 20-30 lines of code into like 5 or 6 just by using a simple mapping function. So all these views, then I separate these out into this view helpers. So that's generating the card code. So if we look at that, view helpers. Yeah, so we took this these two functions which pull in the data. And this is a very simple namespace. It doesn't include anything else, so we can just include this from the actual views that we're creating. So we've got headline card total and headline card country, and it's just generating the information there. I've used the Bulma color for where is it? Yeah, it has text primary. So the has text primary makes the color of the text green. Oops. But I couldn't find a nice color for the other values, so I've just added a specific style here. So you can use a mixture of Bulma styles, predefined styles that they have. And you can still write your own CSS styles there as well. So this is just a very simple color for the color purple. And then we just get that data and yeah, take out the type and stick it to, and we're just basically merging the first part of the key with the second part of the key, and then we can get the value from the data set. So that simplifies my code. So basically using the namespaces in Clojure in this application to basically abstract all this code, and also it makes it a lot more easy to maintain, because if I want to do something with the cards, I can just come to this namespace and just focus on the structure of basically the structure of the HTML I want to generate from Clojure, and it allows me to hide a lot of that data out when we go back to the main dashboard. So we go back to the main dashboard. Boop. Yeah. Then it allows us to have just a very simple function calls that make up the dashboard, so we don't have 1,000 pages of code, 1,000 lines of code in the main namespace. We can separate out specific actions into specific namespaces. And so what else we got? So we've got the namespaces. We've got the views, which have got the Vega views that we created. So there's the line plot and the bar plot. We've got the helpers, and then we've got the data.gov.uk data. So this is the information I've pulled out from the gov.uk. So this is real data, and this is just a wrapper really for pulling out the data from the files. Unfortunately, there isn't really an API from that website. I thought there might be at first, because it does have a URL, but you follow the URL and all it does is just download a file for you. So that's a bit annoying, but if we look at the gov.uk space, well, we already had the mock data here, which I don't think I've changed. So this was just generating kind of the right kind of format of code. So if we were, it's just generating, oops. Boom, there we go. Oh, I've changed that now. Oop. There you go. Change the key bindings for. So yeah, so we've got like a day, a location, and a cases, and then we've got that for each of the recorded pieces of data. So each observation for each day. So if we've got 30 days, we'd have 30 maps, all inside a vector of maps as well. So if we did that work. So we got a sequence, a collection of all these recordings that have been taking place. So that's what we've been basing the charts on. So that's one of the things we need to emulate in the when we're looking at the real data from gov.uk. Okay, so let's have a look at this. So let's have a look at data.gov.uk. And so we started pulling in this for the headline figures from the original version. We were already using Java IO to pull in a file, which adds a bit of nice kind of management around that file. And you could also do streaming files as well if you wanted to. And then we're using the CSV library, Clojure data.csv, to just basically convert a CSV file into a Clojure data structure. So that bit we'd already covered in the last video, really. So we're just basically getting a handle to a file, which I've just now made. I made this kind of like the file to be an argument we're passing in, and then we slurp that into a string. So we read all the contents of the file. So this is like an object pointer to the file, and then we can slurp the content of that object into a string, and then we use read CSV to read the string and convert that into a sort of simple data structure. So if I got that. So we call that, and then we could just inspect this. We've got basically a hash map, so a vector of the data, and the data includes all these keys and values. So this is like the CIDR inspector, which helps me visualize the content of a Clojure data structure. So actually, this is just a key value pair hash map, but this is a nice way to visualize what's actually in there as well. And also, if you've got a very long one, you can step through all the different values as well. So it's a lot nicer view to use in if you're using CIDR. And so we can see all the keys that we can use to pull out values as we need to. And so you can see the names of the keys are all strings, so we'll need to use get rather than just using the keyword. So if I quit that. Oh, and one thing that did catch me out, because this is all spreadsheets, then it's very easy for somebody to just decide to change the name of a heading. So when we did this, you can see that there's a daily UK deaths, then that was the original value, but now they've changed that. So in the new one, so in the latest version of the document I downloaded yesterday, they actually changed to new yoke cases, which tripped me up a little bit. So I thought, well, why is it not displaying? So what I ended up doing was just doing a kind of quick hack to associate in daily UK cases, which was the original name for the heading, and grabbing the value from the new heading. So we get from the data set, we get the new UK cases. We just put that into a local name, and then I'm just associating in a new key, so an extra key that's named as the previous value, the previous key was named with the value from the new key. So that was, again, it's probably I don't know if there's a better way to do that or not, because we basically want to. I don't know if there's a way to change the name of the key without deleting the key and adding another one in. So we may as well just add the key in, and in that way we don't have to change all of our code straight away, and it's we can decide what the best course of action is later on, because they might change it back again, they might change something else, so we can deal with that later on. And it's mainly the fact that we've changed the name. We could deal with that with when we're importing, extracting the data. Here we're just putting a simple fix on there for now to say, well, we'll just duplicate the key with the original name, and that's one simple way to fix it. So it does seem that when you're supporting data science stuff, then a lot of things can change quite easily, especially if there's no structured API. If people are just using files, then your data could change. Your data structure could change quite easily. So sometimes you have to do a lot of transforming of data to make things work and keep things working. So I was using that for the daily cases, and I think I still am. So we've got this. This is for the headline figures here. So they're all up to date from yesterday. And it was very easy to see that something wasn't quite working when I did the view, because this value here just wasn't displaying. So the dashboard was still working. I just didn't have a value, because it was trying to pull out a key from the data set that didn't exist. So it just didn't put anything in this block here. But it still worked, because it's still got a value, but it still had a value of nothing, so it could still work. But it just obviously was a very obvious kind of bug, because I could see visually just by looking at the dashboard that it wasn't there. And then with the dashboard, originally, is this going to go back to? It is. It's going to go back to where it was. No. There we go. So I was just using mock data for these graphs that Vega was using. So rather than do that, then we wired up the data. So there's the daily confirmed cases, which I've used to be able to kind of populate those views rather than using the mock data that we had. So again, this is just a file you can download, but when you download it, it's a Microsoft Excel spreadsheet. So I could have tried to convert that, but it's a multi-tab one, and my spreadsheet skills obviously weren't up to scratch, because there's lots of different pages in here as well with data, and for some reason they've organized this in like rows instead of columns. but then each column is the date as well. So there wasn't an easy way to convert that into like a CSV, not like by just saving the page out into CSV, because we want to be able to tie up two different pieces of information for each value. So it wasn't really in the right shape. There we go. And also I noticed that there's some missing data here as well, which wasn't great. So for the first on the are those American dates? They are, aren't they? Yeah, so on the 9th of March, there was only a record in England, or somebody just didn't include like 0 in here as well. So I don't know if these are 0 or just they weren't recorded. There was no reported cases that day. So what I've done is just taken it from this start point. Just so it kind of makes it even. So like the first day where all 4 countries have reported. Okay. Oops, wrong one. Let's get that there. Yeah, so then we're going to put that onto here, so we can see we've now got 4 days. So England's got the most, and it's going to, so we can see roughly from these values whether our line chart is looking about right. You can see England has the majority of the cases, and so this is just the specific cases we're modeling. We're not modeling any other values here. And the same, this is just a bar chart of this. It's a stacked bar chart with England, Northern Ireland, Scotland and Wales displayed there. So how did we put that together? Let's have a look. So this is also in the data.gov UK file. So I've created, because we're dealing with all the functions that are dealing with the data from gov.uk, I just put in the same namespace. That way it's easier to kind of logically think about them. So initially we've just got the ones that working with the CSV files, and then we moved on to using a library that will help us read from Microsoft Excel files. And so with a quick bit of Googling, I found this Clojure, this Clojure project, which I think I've got a link to here. That's not it. There it is. We've got Clojure, which makes reading and writing Office documents in Clojure easy. And it pretty much did. It did make it a lot easier. There's lots of examples here. So simple. So you can load in a workbook, and the nice thing is you can select the sheet you're working from. So it knows about the different tabs in the Excel spreadsheet, and so you can just work on specific tab, a specific sheet, and then you can select columns, you can select cells, and then there's also like doing things with I don't need to create one. What are these other examples? Oh yeah, iterating over rows and so on. So doing a row seek will get all of the values in a row. And because our data was in, is in these rows here. So then we need to get row data. Then we are going to you basically iterate over cells over an entire row. So we load the workbook, get the spreadsheets, and then iterate over that, remove any nils. And so that's basically, I pretty much copied most of this code, I think just a few tweaks. Okay, there we go. Yeah, there we go. So just as a quick test, I pulled out, so I've just got the loading a workbook from resource. So that means I can put the book into the data file, the resources file inside a data folder, which is the data, and then the name of that folder, which is in there. It's one of those files. Oh, historic, yeah, that one. There you go. And then we want the countries tab, we want the country sheet. And then I did a quick test to just see whether we could get just make sure this was working. So if you get a cell, then it's giving you, it's returning an object that contains that value. And so we do get the right value out there. And we can use something more convoluted here. So we're still like working through using a thread last macro. So we're going to grab the whole spreadsheet with all the different sheets. It's going to load that in, and then we're just going to select a particular country. And then on that country, we're going to get all the rows basically, and then remove any rows that are empty. And then go over with cell seek, and then basically just read each of the cells and produce a nice map of all the data. So if I evaluate this, and then I'm just going to use the inspector again, just to show you. So it's generating a lazy sequence. So this should be like inside round brackets. So we've got a list of lists essentially, and I noticed it wasn't entirely perfect in removing the nils, but so that's something I might be able to tweak. But it gives me the more importantly, like on row 8, it's giving me all the England data, Scotland data, Wales, and Northern Ireland. So these are the pieces of data I actually want to get. And but it's not quite in the right format. So it's not in the same format as we were generating with the mock data, because in the mock data I had each of these values was a map, was a value inside its own map. And then so I want to be able to convert this sequence of this area code, and the area code is, we'd use that if for a GeoJSON geographical view of the data. So if we want to let's just open this up again. So we want to create an image like this. So here, so England, this would have a geographical area code, which is this E number, or England, Scotland, Wales, Northern Ireland, I guess. There we go. So these are, I think they're fairly standard kind of geo codes that you can use for your creating geographical maps of visualizations. And then we've got, so you got the country, but then we've got the individual data as just additional elements in that list. So we want to be able to take each of these values, so like 280, that wants to be associated with a cases key, and then England wants to be associated with the location key, and then we also want the date as well. So we've got the dates up here somewhere. Yeah, so we've got the dates. Oh yeah, it's in the line previously. We've got all the dates that are that match up with the values. So each of these values were taken on a particular date. So then we had to just basically do a bit of data transformation to make that all work. And this is a bit messy, this code, I think, but I was doing it last night, so apologies. It's not the most streamlined code we're going to cover. Getting the dates was fairly easy, so I created a function here. I'm pulling in a data set, so I did try and figure out how to do this a bit more elegantly, but basically I'm getting the data set I want on the line number I want. So we have a look at line number. If we go look at our spreadsheet, let's make this bigger. Boop. Oopsie. So line number 8 in the spreadsheet is the dates. And if we go back to our cumulative cases, let's look at the inspector again. And that equates to, when we've converted that into a Clojure sequence, that's the kind of the 7th element inside the sequence that was being generated when we pulled in all the data from the Excel spreadsheet. So we need element number 7. So we're just using nth to get the 7th row of the data, which is the which has all the days in it, all the dates in. And then we're going to drop 3. Oops, let's put that back again. We drop 3 because we don't really want the area code, and we don't want the area name. We just want the dates, and we don't want the first date, because, as if you remember, that only has the England value in there. It doesn't have a Northern Ireland value. So to make everything consistent, we're going to drop the first date here, and so we'll just start with Tuesday, the 10th of March. And so this basically is just going to generate a collection of dates. I'm just basically getting the dates, just the specific dates I want from that line, and dropping the first 3, and then running a little function over the dates, just to basically add the key day to the dates. So we've got basically a hash map of day and then the actual value of the day, and just using map v to generate a vector, although strictly I don't think that's too important. So if we evaluate that and then we call it, then we get day, and we got the instances of day, and I thought I might need to do something with that, but Vega seems to be happy with putting the basically using this date format. It doesn't seem to have any problem with doing that, so that's quite nice. Obviously it's using that as a display, so we might want to just simplify this, remove the time element from this, and just make it a date, and that would make it a simpler view. If we go back to Oz here, if it's still there, so you can see all the day labels are all kind of quite verbose there, so you might want to change the data just for those labels, although you can override the labels as well if you wanted to. Oops, oh, I'm clicking on the wrong screen. There we go. And then I did the same thing for countries. I actually did this first, and it's a bit more messy. Apologize, but did the kind of same thing, and I think, oh yeah, I've refactored this a little bit. So we're pulling in, we're getting the country, which is the second value from the data set that we're passing in. So this time we're actually passing in a particular line. So I'm going to call this COVID UK countries data cumulative cases map. That's getting a bit of a mouthful, actually. And I'm passing it in with a specific line. I want a specific row of the data. So I want, in this case, I want row, so the 8th element, which is the one that matches England. And so from that row, we're getting the second data set, which is the country, which is England, but there's a space on the end of it. So I've basically just used trim to just make sure that there's no spaces in the strings afterwards. And then with the values, again, I'm dropping the first 3 from the data set, so that we actually we start on the same day. and that keeps it nice and clean. And then again, we're just creating a hash map. We're tying up location to country, and then cases we're getting on from a value. And then this is when I realized I'd forgotten to include date, so that's why the date is separate. But what we're doing is just doing a map merge of the dates over the results of creating this location and cases thing. So it's not the best code, but basically we do, when we do get this, we get oops, that's not right. We do get the shape of data that we wanted to. So we've got location key, which is England, cases, and then the date. So we can use that in our Vega line plot and stack bar very easily, because it's now the right shape for those to work. Oops. And I created one for each. Again, this is a bit repetitive. This is why I probably need to refactor all this code. It's basically just doing the same thing for each country, and then I just stick them all together with a big concat. That's probably not code that will get you a job in a job interview. But I was doing it quite late last night, and it does work. That's the main thing. You can always refactor something later on. And so when I look at this, and again, I really have kind of benefited by using the CIDR inspector for doing this, because all the nice things is it does let you walk through all of the data. It does some pagination of the data, so you can actually skip through. If you do N for next, you can go through, and I can see all of the data very easily. Yeah, so I can move backwards and forwards through the data. I think this is when I realized that yeah, there was a space between there was a space at the end of the location names. Good. And then yeah, so basically all I'm doing is just doing a merge for the countries, and then concatenating all of the different, so the merge for the date, and then a concat for the different countries, putting them all in a single data structure. So then we're using this all cumulative cases, which is what I put into the main dashboard. I think, where are we? Oh, so the views are in the dashboard, but for the views, I've got a view. I've got this view namespace. Oops. So all the namespaces are in these vega-lite components as views. And so that's where I moved all the kind of the original line plots. So this is the line plot using the mock data that we had already, and then I've just basically just replaced the values with this all cumulative cases, and that's all I needed to do. So once you've got the data in the right shape, then it's very easy to just plug it in to your existing views. And the only other thing I did was to add height and width, because they were looking a bit small when I was displaying them, especially compared to the rest of the web page. So I've added these extra options in the visualization map, and these were just from doing the in here in the config, in the Vega config, so you can add height and width and some other data in there as well. There's all sorts of different properties you can add, again, to help you visualize that data quite nicely. If you don't put width and height there, like Vega will still put some defaults in there as well, so you don't have to put them in straight away. See what the defaults are, and then add things as you think you need them. So I've got this line plot, UK countries cumulative cases. And then for do the same thing for stack bar. And again, it's exact. I didn't change anything else. Oh, I didn't even change the size of this actually. And then, yeah, so all I did was just change the values. The data UK gov instead of the mock data values, and that worked. Boom. So that gave us the. Oops, wrong one. That gives the real data in those plot charts, because then I just called those in the main dashboard namespace. Boom, boom, boom. So that's all the Bulma headline values, and then I just updated this section to call, rather than call the line plot, I'm using the line plot UK countries and stack by UK countries. And that was it. And then I just added this Oz view to the main, so you can call this on the command line, run this as an application, and it will. You give it a dashboard, and I might sometime make that a default, or give it a message so you can kind of tell you what views are available. But essentially, you could just run this on the command line with just passing in the view that you wanted to display. So I do that, and then oops, we got the dashboard. So that's all I've got working so far. But there is one other thing I was looking at, and there's a bit more work involved. But it's actually to have the this geo map done here. I think this, I've got the data for this now as well, so this should be fairly easy to do. But there's other things I'd like to do, like put in the relative number of like population in each country as well, because these it's hard to see, because you look at the kind of the size of Scotland and England, and there's not a huge amount of difference. But there's a lot of difference in terms of population size. So actually having the number of people who live in those countries would be a useful, I think it would be a useful value to include as well. And there might be some other visualizations to do that as well. So I'm going to try and find some information that's up to date on that. But also trying to do the GeoVis stuff as well. I haven't got this working quite yet. Essentially, you need to go and find a where is it? You can find this the right GeoJSON file, and there seems to be quite a few of these, and it's basically a file, and you can see that it matches up with these values. So you've got like the England location, so all the regions and locations in England have got like an E number. And so you can match that up with the data. And there is so to get an image, it's not that difficult to get the actual plot, because I've got this geomap plot that I found, so I can create the actual layout. Ta-da, there it is. But there's no information on there, so that I just need to map the information onto the geomap. That's the next thing to do for next time, hopefully. And this geomap here, if we go to the views, Vega, there we go. So there's a few different maps I've been trying. So basically, I'm just using these JSON files on the internet, and basically just using a Markov GeoShape. So that's the visualization I want. We define a URL, so rather than values, we're pulling in kind of values from this, and just defining that it's a type of JSON, so you can display it, and just giving it a size, because it's quite small otherwise. but that's not showing any of the actual data. So the next step is to apply some data to this map, and then that's what we draw. So I think there's some examples in, not that one. Oops, I want to do that. Inside, oh yeah, applied science. Yeah, so there's some examples here. That's what we're trying to do. It's trying to show kind of the relative cases, and just using color visualization to kind of show like the concentrations in which areas as well. So I'm going to walk through some of that and get that working for the UK as well. And there is a working project for this as well that you can go in, and this is all using Vega and Clojure as well. So I'll include the links to that in the chat. Okay, well, I hope you found that useful, and if you have any feedback on what else you want me to do, or any kind of other aspects of Oz you want me to cover, then please let me know. Yeah, there we go. And so you can get in touch with me again via Practicalli on the Clojure in Slack, or you can contact me via john@practical.li. Let me know. Let me know if you're enjoying these things, any kind of feedback you have, and anything you'd like to see in the future. Okay, well, I hope you have a safe and isolated long bank holiday, and I hope you all stay safe, and I hope to see you all next time. Thank you very much, and goodbye.